Is reality just an illusion? The quantum experiment that fooled the world? Close your eyes for a second. Now open them again. Everything you're looking at right now, is it real because you're looking at it? Is your own consciousness somehow creating the world in front of you? It sounds insane, but here's the strange part. The founding fathers of quantum mechanics, the most successful scientific theory humanity has ever built, genuinely wondered the same thing. And centuries earlier, ancient Hindu philosophy had already been describing the physical world as Maya, illusion. So are science and spirituality about to collide? Stick around, because by the end of this video, you'll understand something even most physics graduates get wrong.
The 2-century fistfight over light. To understand this, we have to go back to history's most famous experiment, the Double Slit Experiment. Almost everyone has heard of it. Almost no one truly understands what it means. In the late 1600s, physicists split into two camps. Team Newton insisted light was made of particles. Team Huygens, led by Dutch physicist Christian Huygens, insisted light was a wave. Because Newton was the reigning celebrity scientist, his particle theory dominated for the next 100 years. Then, in 1804, British physicist Thomas Young ran the double slit experiment and produced an interference pattern, something only waves can do. In 1819, French physicist François Arago backed it up with his own wave-based experiment. Score: wave theory 2, particle theory 0. But particle theory wasn't dead. In 1905, Einstein's photoelectric effect showed light physically knocking electrons out of atoms, behavior only a particle could produce. In 1923, Arthur Compton showed X-ray light transferring energy to electrons on collision, exactly like a particle smashing into another particle. Score: 2 and 2. Eventually, physicists had no choice but to accept something deeply weird. Light is both, a wave and a particle at the same time. Scientists call this wave-particle duality, and it marked the true beginning of quantum physics.
Then, matter joined the party. If light could be both a wave and a particle, French physicist Louis de Broglie asked an obvious next question in 1924. Why not matter too? Why not electrons, atoms, everything? In 1927, American physicists Clinton Davison and Lester Germer tested this directly and proved it. Electrons, protons, all matter behave like waves at the quantum scale, which means, at that scale, particles don't have one fixed location. They exist as a spread of probabilities, a cloud of maybe here, maybe there. And yet, zoom out to the world we actually live in, and everything behaves like solid, located objects. Somewhere between the quantum world and our everyday world, that wave of possibilities collapses into one definite reality. For 100 years, nobody could explain exactly how or why.
Physicists Niels Bohr and Werner Heisenberg had an idea. What if you placed a detector at one of the two slits to watch which path each particle actually takes? Their reasoning made sense on paper. To observe something, you have to interact with it, shine light on it, bounce a photon off it. So maybe that very act of measurement is what forces a fuzzy wave to snap into a definite particle. This idea became known as the Copenhagen interpretation. And this is exactly where things went off the rails. Mystics and self-help gurus ran wild with it. Nothing exists until you observe it. Your consciousness creates the universe. You've probably seen videos making this exact claim. Even Einstein was uneasy, famously needling Bohr by asking whether he truly believed the moon disappears when nobody's looking at it. The problem in the 1920s was that nobody had the technology to actually build a precise enough detector and test this properly. So the mystical interpretation stuck around, unchallenged for decades, even among some of quantum theory's own founders.
Fast forward to 1970, when German physicist H. Dieter Z finally ran the real-world version of this experiment with an actual detector, and the results told a completely different story. Consciousness had nothing to do with it. Here's what actually happens. A detector watching one slit works by bouncing photons off the particles passing through, the same way sonar works. But that bounce isn't gentle, it's a physical collision. Each collision knocks the particle's wave slightly off its original rhythm, its original frequency. Multiply that across countless particles hitting the detector at random angles, and their once synchronized wave pattern falls apart completely. Physicists call this decoherence, literally the loss of coherence, of sync. Once that shared rhythm is destroyed, the particles can no longer combine into the elegant interference pattern that a wave produces. Instead, they land on the screen as scattered, localized points, which is, by definition, exactly what a particle looks like. No soul required, no consciousness required, just physical collisions scrambling a wave's timing.
Why doesn't a tennis ball do this? This also finally explains why the everyday world never looks quantum. A tennis ball contains around 10 quadrillion atoms, each with its own tiny wave function. For the ball to behave like a wave, every single one of those atoms would need to vibrate in perfect sync, like 100 dancers all hitting the same beat at once. But the ball is constantly bombarded by air molecules, light, heat, and vibration, all knocking those tiny waves out of rhythm. The odds of all 10 quadrillions staying synchronized are essentially zero. So the wave nature doesn't vanish, it just averages out into what looks, for all practical purposes, like a solid particle-like object. Interestingly, physicists have actually managed to keep small groups of molecules in sync long enough to make them behave like quantum waves, hinting that, in principle, decoherence is a matter of scale, not some magical boundary between quantum and real.
So, no, reality isn't waiting for your gaze to spring into existence. The universe isn't an illusion sustained by consciousness. It's built from countless particles constantly bumping into their environment, losing their wave-like sync and settling into the solid, predictable world we experience every day. The truth turned out to be even more elegant than the myth. Not magic, not mysticism, just physics, patiently doing what it always does.